Okay, so maybe I start now because the lesson is recorded. So today we'll look at another rules which will help you to solve spherical triangle. The first rule is about the sine rule or law of cosine. What does it say? It says that, okay, suppose you have a spherical triangle. Okay, spherical triangle. So let's draw spherical triangle. Get three sides here. So usually the curves, they are all in curve here. So three corner of spherical triangle. Let's say this angle A, this angle B, this angle C here. And then so the side opposite angle A is A here, small a. The side opposite angle B is small b here. The side angle opposite angle C is small c here. So the sine rule say that, okay, so I use color code there. So if angle A here, so this angle A here, and the side A here, if take a ratio, sine of A over sine of A, sine of side A, is the same as side of angle B here, and the side of B, sine of them. And also it's the same as the ratio of side of C here over sine of angle C here. Okay, so this is called sine rule. Okay, this is called sine rule for spherical triangle. So make sure that you have spherical triangle here. So this is for spherical triangle. Now this spherical triangle need not be 90 degrees now, any angle. And so there is no state of like the Napier's rule, you specifically have 90 degree. Okay, so this one is for spherical triangle, you have this ratio. And how about plane triangle? Just recall for plane triangle. Okay, if you have a plane triangle, yeah, a triangle ABC here and side ABC here, so straight line here, so A, B, C. Okay, this angle A, angle B, angle C now. For plane triangle, the sine rule say that, okay, sine of angle A over side A, no more sine now, is same as sine of angle B over side B, so and sine of angle C over side C. Okay, so this is A here, this is B here, this is C here. This is for spherical, this is for plane triangle. Okay, plane triangle, this is what happened. So you notice the difference here for plane triangle here and spherical triangle. Okay, so this is the spherical triangle, this one. Okay, so let's see how is everybody doing now. Okay, I have now okay, 23 of you now. Okay, so I think there are two more missing. Three. Okay, so four more missing here. So just okay, so let's continue the example. So the first example to illustrate the sine rule as example 3. Okay, last time we do Napier's rule example 1 and example 2. So this example 3 now. So let's read the question first. I have a spherical triangle ABC, and let's draw the triangle first and see what happens. So ABC, so draw it here. So maybe I draw in a corner better. Let's draw in the corner. So just say this is side A here, this side B, angle B here, this C here. Okay, there's no mention of 90 degree now. So side B is 80 degree and angle B is 120 degree. So this side B here, 80 degree. All the side and angle are measured in degree. So this degree here. And then angle A is 40 degree, a small angle here. So this 40 degree now. So I think let's use a blue color here. And then find the side A. So A is what we want now. So a very straightforward question. Okay, so this one definitely cannot use Napier's rule, right? Because there is no right angle triangle unless you create right angle now. Okay, so but anyway, you can use the sine law, cosine law. Okay, this is sine law now to do calculation. So you can write down the answer for sine law here. First, the sine of angle A, sine of sine A is the same as sine of angle B over sine of side B. Okay, so we're going to find out sine of side A now. So sine of side A, after you rearrange them, is equal to sine of angle B A here, rearrange them, is sine angle A times sine of side B over sine of angle B. Okay, rearrange them. Okay, sine of angle A, sine of side A here is actually sine A times sine side B over sine angle B here. Put in the value here. So sine A is 40 degree. Sine of side B is 80 degree, sine 80 degree. And sine of angle B is 120 degree. So you can press your calculator and see what it is. Now, I think you get 0.7310. Okay, so Okay, so now you find A now. A is equal to sine inverse of 0.7310, and then you get 46 degree 58 minutes as the answer given to you. Now remember, when you apply the sine rule, there are two possibilities. Okay, remember when I talk about sine. Okay, so I just draw a picture here. So this is theta here. This is 180 minus theta here. 180 minus theta here. So what we have is a sine of 180 minus theta is actually the same as sine theta. Okay, 180 minus theta is the same as sine of theta here. So there is another angle. Okay, another angle I can set right here. So or
Sir, I got a
yes,
question.
yes,
So
question.
basically, we can use this sine rule even when it's a not right angle triangle.
Yes, actually, sine rule has no restriction of angle. So if as long as you fit in the sine rule here, there is no mention about 90 degree. So any spherical triangle, okay, as long as spherical triangle, okay, you can use the sine rule as long as it can fit in. Okay, so it's very flexible, except that you have to take care of there are two possibilities of sine rule is actually 180 degree minus 46 degree 58 minutes. Okay, take subtract this one, and then you'll find that this now is actually 135 degree and 2 minutes. Okay, 0.2 minutes. Okay, however, as you know, any triangle, the bigger the angle, the longer the side. Okay, we find that for a bigger angle, this one is 120, the side is 80 degree. Okay, so 40 degree cannot be more than 80 degree now. Okay, the angle A is 40 degree, right? Since angle A is 40 degree, so the side A now, okay, the side A cannot be more than, okay, side A we know that cannot be more than 80 degree, right? Because angle B is 80, the angle B is 120, but side B is 80. So this thing cannot be, so this one must be less than 80 degree, right? Because the longer side is B, okay? Longer side is B, so it is B, okay? Longer side is B. So therefore, you must reject this answer. So reject. Okay, reject this answer. So you have A is actually 46 degree 58 minutes. All right, so this is how we answer example 3. So I'll WhatsApp this to you. Let me see. Skipping here. Okay, that's WhatsApp this to you here. Okay, so let's go back and then see how is everybody doing now. So except David not here yet. No, still the same. Okay, there's 4 people still haven't joined yet. Okay, so there is example 3. Okay, so next one, example 4, right? Okay, example 4. Again, a very straightforward application of sine law. And notice that, okay, look at how we phrase the question. Usually, if the question try to help you, they'll tell you which law they use, okay? So for example, here, the law, which law will tell you, they'll tell you which law you use, huh? So for example, use the sine law. Okay, you can use the sine law. Use the sine law to find C, okay? In the example 3, you look at question, okay, you'll see that they ask you, this one they didn't ask you about this, but the next question is you, okay, use the sine law. Okay, so you just use it lah, because then it help you. Okay, so let's try to draw a spherical triangle first. So I try to draw as accurate possible lah. So this time, okay, so a bit tricky here, this one. When you draw it, maybe first time it's not correct. Okay, that's right. So you have 3 angles. Okay, so let's draw it first. I think try to draw a curve here so that you don't get misleaded by this bigger triangle here. Okay, angle A is 45 degrees. Side A is 50 degrees. Side C is 60 degrees. Find angle C. Okay, angle C is what? So if you use color code here, so this 60 degree is the side C here. Okay, this is the angle I want to find. And then I know A, angle A and side A here. Okay, use the sine law. So you write down the sine law here. So this is sine of angle A, because they're given A and side A here. Then the sine of angle C, we don't know what is angle C here. Sine of side C. I remember the sign there. So arrange them. You get sine of angle C, which we want to find, equal to sine of A, sine of side C, over sine of side A. So putting the answer, sine of angle A is 45 degrees. Here, Sine of side C is 60 degree. Sine of side A is 50 degree here. So now let's find out the answer. Okay, this time you get 0.7994. Okay, 7994. Okay, so I get miss a 7 here. Okay, so find out what is C now. So C is equal to sine inverse of 0.7994. The first answer you get is 53 degree 04 minutes here. Okay, so this is one possible answer, okay, as given by the answer here. But there's also another answer, right? So what is the other answer? The other answer is, okay, this one is tricky here. To draw the theta here, and another theta here. So the first answer is this one, 53 degree 04 minutes. The other answer would be this one, 180 degree minus 53 degree 4 minutes here. So there's another answer here, or C equal to 180 minus 53 degree 4 minutes here. As the answer show you, this is another possible answer. Okay, C is 126 degree. So do you know which one is correct now? How come the answer say there are two possibilities? Because now the side is 60 degree, right? So the angle must be more than 45. The angle C must be more than 45 degree. Okay, so this is here 60 degree here. So that means that the angle C from here must be more than 45 degree, which we have one here already. Okay, 45 degree, right? So C is 60 degree. So the small side C, right? The small side C is 60 degree here. So the angle C must be more than 45 degree. Okay, the answer C must be more than 45 because it's 60 more than 50, right? Right. So we know that this is correct here. So how about the other one? It's also more than 45 degree, right? So this is also correct. Also correct. Okay. So both are correct here. So where is actually angle C? Yes.
Anyone is less than 45 degrees, therefore that option is voided.
Which one?
For this kind of question, if it's less than 45 degrees.
The angle A is 45 degree, right? The A is 50 degree. Okay, A is 50 degree. The side A 50 degree. So 60 degree is more than 45 degree, right? 60 degree is more than 50 degree, right? Okay, 60 degree is more than 50 degree. So we know that the angle C must be more than 45 degree. Okay, angle C, the bigger the angle, the longer the side. Okay, the bigger the angle, longer the side. Now the side is 60 degrees, so we know that the angle must be more than 45 degrees now. The C must be more than 45 degrees now. So we have 53 degrees, which is okay. So the other one also more than 53 degrees now is 126. Okay. So why is it C like that here? If you draw it, could be this way. What happens if you draw C this way? If you draw the C, let's say this way. Okay, let me draw it more accurately here. So if I draw C this way, you can see the angle here. So if I draw a triangle this way, let's say C is here now. Okay, then this angle 126 also correct. 126 degree, 56 minutes. What you have is actually this one is 53 degree 4 minutes. So if you draw the triangle, if you put a different C, right? If you draw the smaller angle, okay, you can see is 126 degree 56 minutes here. This is also possibility. Okay, then because a big 60 degree corresponding to 126 degree 56 minutes now. Whereas, okay, if you find C is 53 degree 4 minutes, also can, because you draw a big triangle. So two possible triangles that give you the possibility. And that's why the Sine law have this special consideration. Okay, so this one, take note of situation. So I WhatsApp this to you. Example 4. Okay, let's go back and see how's everybody doing now. Okay, still have I think 3 more missing here. So what I show you is a Sine law, right? So let's see if one copy can copy this one. Okay, so let's move on. Okay, let's move on to next one is called cosine law here. Cosine law is also will be given to you in the MST and given to you in the exam. Okay, so cosine law, okay, so law of cosine here. This is again for a spherical triangle. There's no mention about 90 degree, so need not be 90 degree here. So I have, let's see the cosine law say, right? So the first statement you look at cosine law is how everything tally here. So I just look at the first statement of cosine law. There are three depend on how you make it the angle here. So cosine law here, cosine A equal to cosine B cosine C plus sine B sine C cosine angle A. So basically looks like a law of cosine. The first two terms are cosine, second two terms are sine and the angle A. Okay. So how do you actually remember this angle? So you want to find the cosine of side A, right? Cosine of side A. So you start with side A first. A, cosine of side A. Okay, cosine of side A. The corresponding is to find the cosine of side A, you must find cosine of side B, cosine of side C, okay, plus sine of side B, sine of side C, then finally angle cosine of A. So this is how you remember this formula here. Okay, so if I use color code, cosine of side A. Lastly is cosine of angle A. Then afterwards, then let me use a different color so that you can see the difference here. Cosine of B, so B is the green color one. Cosine of B, sine of B, then cosine of C, sine of C. This is how everything tally. Okay, so if you want to try, so this formula is for you to find, what is it for? To find side A. Okay, to find side A. Okay, this is for you to find the side A. You can use it to find side A. What happens you want to find side B? So you can draw another different triangle here. So same thing, I want to let you see the difference here. So this is B here, side B, this is A, C. Okay, if you want to find side B, so what you do is, okay, this is side B here, side B. Okay, so side B here. The last one is angle B. Okay, angle B. Then the other side, just color as you want. So suppose I want to green color to be side A now. So side A, green color here. So this one will be cosine A, sine A. And then blue color one is actually maybe small letter, like better don't get confused. So small letter here. So this will be side C. So the side C, cosine sine C, right? Small letter. So you can actually follow this pattern to find the side A, side B, side C, right? To find the side A, same thing here. You can have side A, side B, and side C. Okay, this is the cosine law for spherical triangle, right? For spherical triangle. Okay, especially a spherical triangle here. So, must highlight to you this spherical triangle. Again, no restriction on 90 degree. Okay, triangle can be any shape here. Okay, this is for cosine law. So let me WhatsApp this to you, although this is actually in the note there, but I think you should know how everything are aligned, arranged here. So let me WhatsApp to you here. Okay, so we have sine law for spherical triangle and plane triangle. How about, remember the sine law for plane triangle there? Maybe I try to highlight to you. Okay, let me sine law for plane triangle, right? So suppose you recall, if a triangle, plane triangle, so triangle plane ABC now. So A, B, C, and then this side B, this side A, this side C here. For a plane triangle, what is, remember the cosine law now? Cosine law, let's say how to find A square now. So to get A square equal to, okay, B square plus C square minus 2BC cosine angle A. This is cosine law. Okay, so this is cosine look like for plane triangle. For the spherical triangle, okay, for spherical triangle look very different now. Okay, now you get cosine A. Okay, cosine B, cosine C plus sine B, sine C, cosine A. Okay, for plane triangle. So notice the difference here. Okay, so plane triangle, this one, right? So just write down so that I can make comparison. So WhatsApp this to you because you may not aware of this because sometimes you forgot already how the plane triangle look like, the cosine law. So the cosine law we have mentioned earlier. Okay, this is the cosine law here. Okay, this is the cosine law here. Just mention this one. So find side A, side B, side C here. Now, how about what the other use of cosine law is to find the angle? Okay, this one is find side A, B, C. Okay, can you find angle now? Yes, you can also find angle using the same formula. Okay, so I'll start look out the solution for this working here. You can actually find out the angle here, right? So what I do, I'm going to show you how to get this formula for cosine A. Just the rest the same as the same arrangement. So we start with cosine side A first. So you start with cosine side A equal to cosine side B cosine side C plus sine side B sine side C, then cosine angle A. Okay, so this is actually for a spherical triangle. If you draw it in this way, like so, spherical triangle A, B, C. The side A, side B, side C. So I want to find angle now, okay? To find angle. Okay, just now I want to find side. This is find angle now. So I must arrange them. So I can find this cosine A first minus cosine B cosine C. This is equal to sine B sine C cosine A, right? It's just what like this. Cosine A minus cosine B minus cosine C. The left is sine B sine C times cosine A. Now divide everything by sine B sine C now. You get cosine A minus cosine B minus cosine C divided by sine B sine C. This will give you cosine A. Angle A, right? So by this, you can find out what is A now using this calculation. So this is how you use it to find angle. So you can find it for angle A. So what happens if you can find angle B now? Okay, so similar calculation. You want the angle B now. Okay, do you see the pattern here? I mean, purposely do color here. So this A, and then the other side. Okay, this angle A here. So now this B now. So if you want to write down the same formula, the pattern just the same. So you write with right cosine B now, yellow one. Okay, same. Then minus the other two. Okay, so you actually only A and C now. So this is cosine A, cosine C. So A and C, then sine A sine C. Okay, so this will give you so A and C, right? The other two. Okay, this is how you use it to solve the angle you want. Okay, using this method here. So maybe I WhatsApp this to you, help you remember. Okay, let's see us and doing. Okay, so that's it. Okay, slightly better. Now I get, I think, 25 students. So I think still two missing. Okay, so let's look at example, how to use it. See the nature of question. It is a plane triangle. I mentioned to you. Example 5. A spherical triangle XYZ now. So you can try to draw as accurate as possible first. Never mind if you draw it wrongly, you can adjust also every time you think it's not quite right. So your triangle XYZ now, I draw on the side here. So let me draw a curve here. X, Y, Z. Okay. XY is one side XY is 110. So this is XY here. 110. 27 minutes here. YZ. Okay, so this YZ here now. YZ is 63 degree. 42 minutes. And the angle Y, this one is 94. Find XZ. So XZ is what now? So this is a classical example to apply the law of cosine. Okay. When you see this type of diagram, you know that must be law of cosine, whether it's plane triangle or spherical triangle, right? Oh, then this pattern, okay, you know the two sides and the angle in the center, you find the third side. It's always law of cosine. It's just that now you build a two spherical triangle now. So let's try to do a spherical triangle XZY. The formula for XZ here is actually, let me highlight what you do find now. I do this one yellow, this yellow here. Okay, so let's see, I call this green here. This is blue here. Okay, so the cosine of this, you can write cosine of the XZ here. Okay, XZ here, yellow. Okay, cosine XZ here. So what is it equal to? It's equal to cosine of two other sides. So one of them is cosine of XY and cosine of YZ, then plus sine of XY, sine of YZ, and then cosine the angle Y. Okay, I use color code to show you that how are they correspond. So Y is the yellow one, angle. The other one is the two side here. So I use YZ here for blue color. So the YZ blue color here, and then this is the green color one. Okay, so now put in the number. So this is equal to cosine of 110, then cosine of YZ 63, then by sine of 110. Okay, let me shift this a bit here. Okay, sine of yz now. (56, 63° and 42 minutes here. And cosine of y, cosine of 94°. Let me shift this a bit here. (94°, 21 minutes). So then you press calculator. So this is a lot of calculation, a long-winded calculation. Okay, so you'll find that this will be equal to we are actually trying to find out what is the exact, right? Okay, so I think you get, if you press the calculator correctly, you're going to get a negative answer now. So this answer is actually minus 0.2185. So the side xz, right? The one opposite angle y. So xz here is equal to cosine inverse now. Okay, cosine inverse don't need to worry because there's only one answer only. Unlike sine inverse, there are two possible answers. There are only one answer only, and this time you get 102° and 37 minutes. Okay, let me use color code also to highlight to you that this is how the calculation is done. This one, this one, this one, this one, this is y. Okay, so eventually you can accept it. So let me WhatsApp this to you. Okay, I think everybody want to accept Tarzan not here yet. Okay, so let's show you the last example I intend to cover. And by the way, your MST will cover until law of cosine, right? Law of cosine is the last topic. topic we cover in MST. Okay, so example 6, in triangle ABC, and then they are asked you to use law of cosine to find angle B now first. So this time finding angle, right? Just now finding the side, now finding angle. So let's draw the triangle on the side first. So try to draw the curved triangle, spherical triangle, as far as possible. So A, B, C. The side AB is 50 degree. So this is AB, right? It's side C here. So this actually C here. It's actually 50 degree, 10 minutes. Okay, side C. AB is a side C here, opposite angle C. The side AC is actually opposite angle B. So this is side B here. This is 64 degree, 17 minutes. And this is side AC, which is opposite angle B. And BC now is opposite side A here, angle A here. So this is side A here. So 27 degree, 37 minutes here. Use the law of cosine to tell you, even I tell you how to solve this problem, okay? They even tell you how to solve this problem. Use the law of cosine to find angle B. So use it. Unless I don't tell you, then you think, oh, which one to use, right? Sometimes both can be used, right? Sometimes you can law of sine, law of cosine, up to you. This one they tell you, okay, law of cosine I think must be the fastest way now to find, because you don't have any angle. Okay, so yeah, start with law of cosine here. So to find angle B, where is angle B? Angle B is this angle here. So let me try to use the color code here. So this angle B, this is side B. Okay, angle B and side B here. Okay, angle B and side B. So the other will be A and C now. Okay, so you can put this okay now, A and C now. So let's write down the answer for law of cosine. If you cannot remember, anyway, these will be provided in the MSc and so also the exam. So let me write down the law of cosine first. So usually I want to find B, right? So let's start with B now. Cosine of side B, okay, equal to cosine of side A, cosine of side C, plus sine of side A, sine of side C, cosine of angle B. Okay, so this is how everything are related here. If you want to do color code, this color is side B, angle B, and then the other one is side A, and then side C, side C. Okay, C is this one, A is this one. I want to find angle B, so I must do something like angle B, right? So I can start with cosine A, cosine of B here, minus cosine of A, cosine of C is equal to sine A sine A, sine C, cosine of B, divided both sides by sine A, sine C here, you get cosine of B minus cosine of A, cosine of C, divided by sine A, sine C, this is cosine of B, angle B now. So this is what you intend to find. So this B here, and then A here, and C here. So print the information. I have cosine of B is actually 64 degree 70 minutes here. Minus cosine of A is actually 27 degree 37 minutes, and cosine of C now is 50 degree 10 minutes divided by sine of 27 degree 37 minutes here, and sine of 50 degree 10 minutes here is cosine of B. So again, I use the color code again to show you where they come from. So from here, I can find cosine B now. Okay, then the calculation, the one more step here, the cosine B in this case equal to 0 minus 0.3755. Okay, minus 0.3755. Okay, so then what is B now? So B equal to cosine inverse minus 0.3755, and then the answer 112 degree 03 minutes. Okay, this is how you can find the angle B. Okay, WhatsApp this to you. Okay, so the MST cover until here, right? So what is covered in MST? Later I'll tell you what's going to cover in MST. Okay, so I will tell you what I'll cover tomorrow and what I will cover in MST. Okay, tomorrow I'll cover tutorial 2, question 7 to question 11. Okay, tomorrow I'll try to cover tomorrow to question 7, 11. Okay, so another thing you should submit, if I want to do so, just allow you to submit tutorial 1, right? Okay, tutorial 1, selected question. If I not done so, okay, if not done so, please do so tomorrow. Submit tutorial 1. Tutorial 2, I'll give you 1 more week to finish, all right? Until question 11. So MSC is 15%. Cover, revision, tutorial. Okay, revision topic and the last few chapter of revision topic on Spherical. Okay, revision on Spherical, last topic here, revision topic. And then chapter 1. Okay, chapter 2 up to including law of cosine. Okay, and I think it's 1 hour only. Okay, duration. One hour. I think it's 1 hour. All time, I think I remember 1 hour. About 6 questions. Usually about 6 questions. Okay, and check again. Okay, all formula provided. Okay, all the formula necessary will be provided. So let me put this to you. Okay, so for this, I will stop the lesson. Tomorrow I see you again. Okay, I'll stop the lesson. Okay, I think somebody want to send me a message there. Okay. Okay, so thank you very much. So I'll stop recording now.